All right, welcome back to this video. In the previous video, we started by doing some exploratory data analysis by getting our data ready to build our logistic regression algorithm. Okay, so now that our data is ready, let's start by building our logistic regression algorithm. Okay, let's start by building our logistic regression algorithm. So what we're going to use over here is we're going to import the libraries. Of course, we've imported it earlier on, but I just brought it here so that you can actually see what we actually need before we start building this algorithm. Okay, so we're going to use from sklearn import metrics. Right, I'm going to show you what we're going to use this metrics to do in a moment to come. Okay, I'm going to show you what we're going to use what you're going to do with it, so don't worry about it. Now what we're going to use right now is this logistic regression, right? We are going to build a logistic regression algorithm, so we need this logistic regression. Okay, so what we are doing over here is that from sklearn, right? From sklearn, from sklearn we want this linear model, and from this linear model we want this logistic regression. So that is basically what is going to happen over here. And then after we've imported our logistic regression model, what we do is that we will initialize it, right? We're going to initialize it, and then we store it in a variable name as model, right? We will store it in a variable name as a model. So if you see the logistic regression, right, if you see the parameter that we have a solver that is a little bit linear, right? So there are several solvers that you can actually find, right? So if you are not familiar with the solvers that you can get, right, all these are hyperparameters that you can tune. When we get to hyperparameter tuning, we're actually going to talk about how you're going to do this. But if you don't understand that, you can just do logistic. Let me even copy it from here and then bring it back. Okay, let me just copy it from here and then take it here, right? So you go to the documentation of this, right? You can go to the documentation of, so if you see the documentation will be here, right? So it's always the first one over there, right? So if you go to the documentation, right, it's running this a little bit. Yeah, now you can see over here that you can see over here in your screen, right? So, sklearn.linear model, right? So as I said, in linear model we want a logistic regression, right? So in logistic regression there are several parameters that you can use, right? So if you don't understand any of the parameters, I entreat you to go to the documentation, right? If you go to the documentation, what happens is that for every parameter that we have, for every parameter that we're going to use over here, it says here, and the explanation to these parameters are here, right? All the explanations are here, including some examples that they will even provide you with. Okay, so if you don't understand any of these, right, I entreat you to go through this documentation, right? Go through this, and this is applicable to all the algorithms that we're going to deal with, right? All the algorithms that we're going to deal with. Okay, it's different. For instance, I'm using solver equals a little bit linear, right? So you can see over here, so we have solver equals LBFGS. So what does that mean? You can actually go and then get to understand it, right? So you can see solver, right? So we have different solver. In this case, we are using a little bit linear, right? So we have different solvers that you can use, right? Different solvers, and what these solvers mean, and when you are supposed to use them, they are all being explained over here. Okay, so you can easily go to the documentation and then get to understand that. All right, so when we get to the hyperparameter tuning tool, we will talk about how you're going to actually choose these hyperparameters. Okay, now after we have initialized our model, our algorithm, and then store it in a variable called model. Now this is where we build our model. This is where our model will learn from the training, right? It will learn from the training data that we earlier on split. So this is where our 70% data that we want to use for training, or we want to use it for our model to learn from, will be used. Okay, so we're using model.fit, right? It's more like model.learn, right? Learn from what? Learn from the training data, right? Learn from the training data, that is the S train and then the Y train. Okay, so we give it some of the attributes, and then that is the X variables. Then we give it some of the target variables, so that you can actually learn from both of them. And then when a new patient comes, and then the person is having some attributes, right, which is included in S train, we'll be able to make predictions and predict the class that they are supposed to fall into, whether the person is diabetic or not. Okay, so this is where our model learns. So this is what we refer to as the machine learning. So this model, you can refer to this model as the machine, which is learning from this previous data. Which is learning from the past data. Okay, this is where all the machine learning comes from. Okay. So now, after that is done, after your machine has learned, or after your model, you have fit your model. If you run, you'll get this output over here, right? You don't need to worry yourself much about that one. Okay, now this is our edge test. Now let's say these are some of the patients that have come again, right? So we have these patients, that is the edge train, right? Let me show you what edge train is also having over here, right? Let me show you what edge train is having. Right, so I'm going to use .head to actually show you the head of it. Okay. All right, so this is what S-train is having. So this is what our model learned from. Our model learned from these patients. So let's say that these are some past patients, some maybe the last 6 months, right? These were the patients that you dealt with, right? And then after the last 6 months, these are the new patients that have come in. Now, can you predict whether these patients will have diabetes or not? This one, our algorithm or our model, the model that we built, right, has learned from this one, right? Has learned from this one, and some of the whether the person was, whether they were diabetic or not, right? The algorithm has learned from that, and now if the algorithm encounters this situation, right, this patient again, algorithm or our model will be able to predict whether the person will be a diabetic or not. Okay, now can our algorithm predict based on this new data that it has not seen? Okay, now let's see what will happen over here if we feed that. If we feed this new data, these new patients that are visiting our hospital, right? If you feed that data to this model, so we're going to use the predict function to make some predictions, okay? So we're feeding that to the model, and then after that we store everything in what is called a y predict. I'm going to use this y predict later on. That's why I'm storing it. Otherwise, there's no need to storing it, okay? Now, if we do that, right, and then make some predictions, now you can see that we've been able to make some predictions of some zeros and ones, okay? Where 0 means that the person is not diabetic, but 1 means that the person is diabetic. If you see this 0, right, if we see this 0, right, you can relate this 0 to this first customer, right? Relate this 0 to this first customer. So this first customer has been predicted as not having diabetes, right? Not diabetic, okay? Not diabetic. And obviously, most of them are going to be predicted as not diabetic, right? Most of the patients are going to be predicted not non-diabetic, based on the features that they provide, all right? So now, as you can see over here, right? This is the only thing that we want. This is the only thing that we want. Now, if these are new customers, right? If these are new patients that came in, right? If these are new patients that came in, now our model learned from the old patients that we were having, which is the S-train, right? Which is the S-train. So our model has learned from these old patients, right? And now, since our model has learned from these old patients, it will be able to make predictions based on the new patients that will come. Okay, so now the doctor doesn't actually need to do a lot of diagnosis or everything. What the doctor needs to do is to provide this information, right? If you feed this information to our model that we have built, right? This is our model that we have built, right? So if the doctor is able to provide this, maybe let's just take this one as a patient, right? So this patient comes to the hospital, right? This patient is called let's say this patient is called Sandeep. Okay, this patient is called Sandeep. So this patient comes to the hospital, all right, and this is the test that the person is having, right? So this is the diagnosis that the doctor made based on this patient. Now, if we feed this patient information into our model, we'll be able to predict whether the person will be diabetic, that is 1, or the person will not be diabetic, that is 0. Okay, so that is basically what our model is doing. And so these are some of the features, right? This is the S-test, right, which our algorithm has not learned from, right? So we fit all these, right? So considering all these to be different patients, right? We fit all these to our model here, right? And then we use the predict function. So if you can see here, we have our S-test, right, which is nothing but that. Okay, so our model is now making predictions, so making some zeros and ones. So considering some of the patients as diabetic, and some of them not diabetic. Okay, and basically that's what we want to do. This is the only thing we want to have, right? Something that has learned from our past data that will help us to make predictions on our future data. Okay, that's what we want to actually do. Now, after here, what we can actually do is to check the score. That is how well this model is actually doing, right? And we're going to check the score on the S-test, right, and the Y-test. data. Okay, this is the data that our model did not learn from. If you remember, we actually divided our data into 70, right, into 70%, and then for training, right, 70% for training, and then we say that we want 30% for testing. Okay, so now this is the 30% that we are going to use for testing. Okay, now we are going to use it to test, and we're using the score to check that. Okay, now if we do that, right, then we see the result that we have here. We see that we have 77% or 78% if you want to run to 2 decimal places, right. You can see that we have 78%. Now this is not bad. It's not that excellent, but it's not bad. Okay, maybe we can go back and then start tuning the hyperparameters that we have. For instance, we use solver equals linear, right. We can come back and then change this solver to a different thing. If we go to the documentation, you will see the various solvers that we have over there, right. We will be seeing the various solvers that we have over there. If you go through this documentation, right, there are different solvers that you can actually use, right. By default it's actually going to give you LBFGS, right. And if you go into here, you can see that there are different solvers that we can use. So we can come and then change that solver and see if we are getting different, or if our accuracy is actually increasing, or if our score is actually increasing. Okay, so we can come back and then do such analysis over there. All right, so when we get to hyperparameter tuning, you will get to understand how we can tune the hyperparameters and then get better accuracy. Okay, now the next thing that we're going to do is to build a confusion matrix. Remember that when we got to this stage, I told you that I'm going to show you what you're going to use this matrix for, right? So that is what I'm going to use over here, right? So in matrix, right, we have what is called the confusion matrix. Okay, in the linear regression class, we did not use confusion matrix, right? But as I told you, as we progress, we will be keeping on adding some of the things that are necessary for your journey as a data scientist or machine learning engineer. Okay, so in this case, confusion matrix is actually going to help you as you progress. That is going to help you to know how many of the labels you predicted right and how many of them you predicted wrongly. Okay, so that is what we are going to do now in matrix, right? In matrix, we have what is called a confusion matrix, and then we are passing in our y test and then our y predict. That's why over here I told you that I'm storing everything in y predict, and I'm going to use it later on, right? That's why I created this variable and I stored all my predictions inside. Okay, so that's what I'm passing in over here. That is my y predict, and then the labels, right? We have either 1 representing the person is diabetic, and then we have 0 representing the person is not a diabetic. All right, now after that, after I do this, right, after I create my confusion matrix, I store everything in a variable called CM. That is just a short form of confusion matrix. You can use any variable name that you want. Okay, now after that is done, I'm converting everything to a data frame. Okay, I'm converting everything to a data frame. So over here, and then after I convert everything to a data frame, I store it in a variable called df_cm. That is the data frame of a confusion matrix. So I just a variable name that I choose. But as I told you, if you're choosing a variable name, make sure it makes sense, make sure it's sensible, so that you can actually refer to it anywhere in your code. Okay. What I'm doing in this data frame is that I'm passing in this, right? If I bring, let me actually show you the output so that we can work alongside that. Okay, so that we can work alongside that. So what I'm doing over here is that I first created my confusion matrix. So as you can see over here, right? Okay, as you can see over here, I created my confusion matrix. I store everything in CM. Okay, so I'm going to convert everything, right? I'm going to convert everything. Let me actually change this, my pen over here. Okay. Okay, so what I'm saying is that I first created this, right? I first created this confusion matrix, then I store everything in CM. So over here, I'm going to convert this CM into a data frame, okay? And then the index, right? I'm setting the index. If you remember, in the pandas class, we learned how to set an index, okay? So I'm setting the index to be 1 and then 0. That is the labels that I have, right? And then my prediction, that is the column, right? I'm setting it to predict 1 and then predict 0, and that's what you can see over here. right? That's what you can see over here, predict 1 and then predict 0. Okay, so these are the labels that I have inside there, which is 1 for diabetic, right? For 1 for diabetic, and then 0 for non-diabetic. Okay, that is what is over here. And then this is my Y test and my Y predict that I did earlier on. Okay, and then I set my column, right? I convert everything to a data frame using the pandas data frame function to do that. And then I store everything in what is called the df underscore cm, which is just a variable name that I chose to represent my data frame of the confusion matrix. Okay, so over here I'm setting the length to be 7, right? So that is from here all the way. Let me actually do it this way, from here all the way here, right? That is 7, and then the height here, that is going to give you 5, right? So 5 units and then 7 for the length. Okay, and then after that I am using the heat map over here. So if you remember the exploratory data analysis, when we're using the heat map to see the correlation, right? We plotted the correlation. We actually did it using the matrix form, then later on we use the heat map to actually visualize it. So the same way I'm creating this confusion matrix and I'm using heat map over here to visualize it. Okay, so over here I'm passing in this data frame that I created. Okay, and then I'm using annotate equals true to just to get these numbers on board, right? Just to see these numbers being plotted over here for me. Okay, so basically that is what I'm doing. So let's take a look at this confusion matrix and see what we can infer from it. Okay, now this is my prediction. All right, this is my prediction down here, as you can see. Right, let me change this. I don't like it this way. Okay, this is my prediction that you can see here, right? This is my actuals, right? So originally it is 1. Okay, originally it is 1. So those that are 1, right, that is patients that are diabetic, right? I was able to predict 48 of them correctly as diabetic, right? So my prediction also showed 1. Originally it is 1. My prediction also predicted 1. Okay, and then some of the ones, right? Some of the ones, instead of predicting them as 1, my model is predicting them as 0, right? So these ones were wrongly predicted. Okay, my model was able to predict 48 of the ones as 1, so predicts 1 and then 1. Okay, so where they meet is the correct prediction. This one is out of the ones 37 of them, right? I predicted them as 0, but actually they were supposed to be predicted as 1, so my model was making a mistake here. Okay, if the same way, if we take the zeros, right, my model was able to predict this amount of them. This is nothing but 13 multiplied by 10 exponent 2. Okay, something like that. Okay, so that is what my model was able to predict. So out of the zeros, right, my model was able to predict correctly this amount of zeros, and then 14 of them my model was able to make a mistake, right? So actually they were supposed to be 0, they were supposed to be predicted as 0, but my model ended up predicting them as 1. Okay, so this one was a wrong prediction. Okay, so you can think of this way, right? You can think of it this way. This part of the diagonals, right? So this becomes a wrong prediction. This becomes a wrong prediction. Okay, so out of the ones I was able to predict correctly, right? I was able to predict correctly 48 of them, right? Whilst 37 of them I predicted wrongly as 0. Okay, and then if you pick the zeros, I was able to predict correctly this amount, that is around 130 of them of the zeros as zeros, right? And then 14 of the zeros I predicted them as 1, which was wrong prediction. All right, so you can consider this part as the right predictions. Okay, so this ones will be the right predictions, this one will be the wrong predictions that I made. Okay, but you can see that if you consider the wrong predictions, right, you can see that I'm actually making a huge mistake over here, right? Because if my algorithm is actually predict, that's why the accuracy is actually around 70 something, it's not even up to 80, right? So we can actually go back and then tune this one and get better accuracy. Okay, now if you see over here, right, 37, right, so out of you can see that I was able to predict 48 of them right, 48 of the ones right, and then 37 of the ones as 0. So 37 is too huge. Okay, 37 is too huge. I can reduce it. Okay, now if the person, this one is actually where the dangerous part is. Okay, because I'm saying that if the person is 1, the person is supposed to be diabetic. We are supposed to predict the person as diabetic. Okay, the person is supposed to be as diabetic. Now 48 of those who are supposed to be predicted as diabetic, I was able to rightly predict them as diabetic. Okay, I was able to rightly predict them as diabetic, whilst 37 of them which actually they were supposed to be diabetic, right? These ones are diabetic. Okay, diabetic, but my algorithm is saying that no, they are not diabetic. So wrongly I predicted these 37 patients as not diabetic, but they were having diabetes. Okay, so this is a wrong prediction, and it's very serious, because if the person is having the disease and your model is predicting that the person is not having the disease, then it's very dangerous. Okay, but if the person is not having the disease and your prediction is saying that the person is having disease, that which is 14 of them, I mean, it's not that dangerous. Okay, but if the person is having the disease, right, and your model is saying that the person is not having the disease, then that is very, very critical. So that's why for medical predictions you need to get a very high accuracy, right, around, I mean, in the 90s, right? Your prediction need to have a score in the 90s. Okay, so in order to be able to use this model in production, your algorithm needs to actually be having a high score. Okay, because you cannot classify all these 37 people who are having diabetes, as not having diabetes, and then they will go home and die. Okay, I mean, it's not appropriate. So we have to go back and then start tuning our model, and then make sure that our model is doing well. So when we get to the hyperparameter tuning, we can actually get to understand how we can actually trick this model to make it have better accuracy. Okay, so basically that is it from here. So we will meet in the next tutorial, right? We will meet in the next tutorial. Have a nice day. See you in the next tutorial.